This is a video for how to go about calculating volume and weight density of a given sample in Distance Learning Activity 2.3.1 Material Properties for your Introduction to Engineering Design class. Within the Distance Learning Activity for Materials Properties, as we scroll down, you're going to notice they give you some samples of three-dimensional objects. That could be a sphere, could be a rectangular prism, and it could be a cylinder over here. And there's several different objects, and there's 6 different samples. And as we scroll down, you're going to notice for underneath number 2 that they have weighed each sample, put each sample inside of a graduated cylinder. That graduated cylinder was filled with 70 milliliters of a liquid, and we're seeing how much displacement was given when that object was placed in the cylinder. And then you're also given the dimensions of the object in centimeters. So as I scroll down here, you'll notice that I had diameter for a sphere. We'll have to put that to a radius. You get width, depth, and height for a rectangular prism, and then a cylinder would have a diameter and a height as well. So within the info section of this video, there is a link for you to click and make a copy of a spreadsheet where we will do all of our calculations together. So when you open up the spreadsheet, you'll notice down at the bottom there's instructions on the first tab, and then there is a tab for each type of calculation that we'll do for the material properties. Within this video, we are only going to be doing density. So we're going to click on density. And when we see the object open up here, you can see that I've gone through and I've done a few calculations already just within the sphere and within the calculated volume over here. I'm going to go back and redo those together as a class just so we can kind of take a look exactly what it is we're calculating and how did we find those. So I'm going to go back to our activity here, and within the sphere they give us diameter, and I'm going to need a radius for that in order to do the volume calculations. So I can go back over here to my spreadsheet, and where it says radius right here next to sphere, I'm going to hit equals. And what I want is this diameter, 1.428. So I'm going to put in 1.428, and I'm going to put divided by 2 and hit enter. And we automatically have a function in here, and you can see that function up here that's going to calculate the volume of a sphere. Now that's kind of a little bit of a loaded equation up here, but that is the equation you would use to find the volume of a sphere. And I'm going to go ahead and hit enter. Go ahead and hit enter after that, or tap anywhere on the outside, or hit escape, and you should wind up with that volume calculation. Now for mass, over here on the side, we have found out how much it weighs in grams because we can see the scale here where it was weighed, and the mass in grams is 11.69. So I'm going to put in 11.69. Go ahead and hit enter. Now you'll notice over here it says volume from the cylinder. It's like, how'd you get that over there? I'm just going to delete that out and show you. So I'm going to hit equals in this yellow area, and I'm just going to come over and tap on the volume and hit enter. And you'll notice automatically it went ahead and divided the volume into the grams, or into the mass, and we got 7.667108927 grams per cubic centimeters. That right there is what your volume would be for that specific object. Now you might be asking, well, I got a rectangular prism. What do? We're going to take these numbers and we're going to place them in this area down here for box. So for width, I've got 1.282. For depth, I'm going to put in 1.282. And for height, I've got 5.014. And automatically we have the volume, and that's just the width times depth times height volume calculation. Now what's different for this is we're just going to use this as a calculator up here. I can go back up here and say, well, they got 22.07 grams. That looks significantly larger than this sphere up here. We're going to go back, and for mass, we're going to put in 22.07. 22.07 and hit enter. And for volume, all I have to do is hit equals, and I'm going to come down and tap on our volume number, and automatically it has gone ahead and calculated our weight density. That's how you would find the answer to your weight density question. Now when it comes to the point of where you might want to say, well, how do I do volume from what they gave me here? Well, if I can click on this, it started out with 70 milliliters of liquid, and how high up did it go? In between about 1.5 here. So what we can say is, is our volume calculation, similar? We're right about 1.5 for volume here, within that given amount, and that's one of the ways we could do volume as well for like water displacement. You could say based upon my water displacement, that's the volume that I found. That's another way that's not quite as scientific, but it's close enough to eyeball what that would be. Now for a cylinder, let's scroll down here. We have ourselves a cylinder. The diameter is 0.628. So what we need to do is we need to find the radius. So I'm going to say equals 0.628 divided by 2, and that's going to give me my radius. Go back over here. I'm going to get my height. 10.170, and automatically we're going to have that calculated for us. 10.170, there we go. Now for mass, over here, now if we're just going to use the calculator, we got 4.65. I'm going to put in 4.65 over here. I'm going to hit equals next to volume. I'm going to come over and tap on our volume of our cylinder, and we got 1.476. Perfect. If we by chance, wanted to round these numbers up, we could through up here. So we could, increase the decimal place or decrease the decimal place. If you're trying to round and get that to 1.48, you can utilize those functions. So this has been a video for how to go about finding the volume and weight density of different 3D objects for your distance learning activity for activity 2.3.1 materials properties.